Welcome to aminacademy.com. In chemistry, let us discuss about phase equilibrium. What is phase equilibrium? Phase equilibrium is the state of thermodynamic system in which the different phases of the substance having common boundary surface and do not vary quantitatively. Here, this figure represents phase diagram of water. A system is a set of components that are being studied. Within a system, a phase is a region that has the same composition and properties throughout. Here, two phases. A glass of water and ice cubes is also a system that has two phases. The system has a solid phase and a liquid phase. However, the two phases have the same chemical composition. What makes the two phases in ice water different from each other is that they are different states of the same substance water. Phase do not need to be pure substance. If some salt is dissolved in the glass of water with ice cubes, there are still two phases. A liquid phase, that is a solution, and a solid phase, that is a pure ice. In this chapter, we will discuss more about the phase systems. Next, further, we will discuss about a system. A system is a set of substances and energy that is being studied. If, for example, reactions are occurring in a jar, everything inside the jar is the system. Inside the jar is the system, and everything outside the jar is the surroundings. This is the outside the jar is surroundings. The surroundings are everything not in the system, which means the rest of the universe. That is, rest of this bottle is its surrounding. Next, a phase. Phase in thermodynamics, chemically and physically uniform or homogeneous quantity of matter that can be separated mechanically from a non-homogeneous mixture and that may consist of a single substance or a mixture of substances. The three fundamental phases of a matter are solid, liquid, and gas. Here gas is the vapor here, but others are considered to exist, including crystalline, colloid, gassy, amorphous, and plasma phases. When a phase in one form is altered to another form, that is a phase change, is said to be occur. Next is chemical equilibrium. If you open a bottle of rubbing alcohol, you can smell the alcohol. Some molecules of alcohol have escaped into the gas phase. When you put the cap back on, the equilibrium is quickly reached. A dynamic equilibrium exists when particles are constantly moving between two or more phases, yet not change in the amount of substance in either phase takes place. Molecules are escaping from a liquid phase into the gas at the same rate that other molecules are returning to the liquid from the gas phase. That is, the rate of evaporation equals the rate of condensation. In chemical reaction, chemical equilibrium is the state in which both the reactants and products are present in a concentrations which have no further tendency to change with time, so that there is no observable change in the properties of the system. The system results when the forward reaction proceeds at the same rate as the reverse reaction. The reaction rates of the forward and backward reactions are generally not zero, but they are equal. Thus, there are no net changes in the concentration of the reactants and products. Such a state is known as dynamic equilibrium. Look at this here. Reactant is product back to reactant. This is a chemical equilibrium. What is vapor pressure? Vapor pressure of a liquid is the equilibrium pressure pressure of a vapor above its liquid, that is a solid. That is the pressure of the vapor resulting from the evaporation of a liquid, that is a solid, above a sample of the liquid or solid in a closed container. Examples of substance. Vapor pressure is at 25 degrees Celsius. Here, this is evaporation because it's a container open. This is a container closed. Evaporation with has reached equilibrium in the liquid surface is said to be have reached saturation. Here, its evaporation is further not done because it's a closed. That is saturated. Next, what about further? Vapor pressure increases with temperature. Here about the vapor pressure we'll talk about. A closed container of water, two-phase system in which molecules of water are in a glass phase in space above a liquid phase. Moving randomly above the liquid, some of those molecules strike the walls and some go back to its liquid. An equilibrium in which the rate of evaporation equals the rate of condensation as soon recreated. The molecules in the gas exert pressure when they strike the walls of the container. The pressure exerted by the molecules of a gas or vapor are phased in equilibrium with the liquid is called the vapor pressure. You can define boiling point as the temperature at which the vapor pressure equals to the external pressure. As the temperature of the water increases, the molecules have more kinetic energy, so more of them can escape into the gas phase. Thus, as temperature increases, the vapor pressure increases. This relationship is known as, for the water, at 40 degrees Celsius, the vapor pressure of a water, for example, is 55.3 mm of Hg. If you increase the temperature to 80 degrees Celsius, the vapor pressure will be 355.1 mmHg. That means if heat increases, temperature increases, that vapor pressure also increases in the liquid. Next, phase diagram. Phase diagram is a graphical representation of the physical state of substance under different conditions of temperature and pressure. A typical phase diagram has the pressure on pressure on the y-axis and the temperature on the x-axis. As we cross the line or curve on the phase diagram, a phase change occurs. Here, this is a curve. Through the curve, if you move some points, the phase changes happens. That means gas to liquid, solid to liquid, liquid to gas. While temperature increases, it happened. When temperature reduces, that is a pressure increase means gas become liquid, liquid becomes solid. That means that due to temperature and pressure changes, the phase changes happen. Next is further in a phase diagram has three lines. One line is vapor pressure curve for the liquid gas equilibrium. A second line is for the liquid solid equilibrium, and the third line is the solid gas equilibrium. Next is triple point. The triple point is the only temperature and pressure at which three states of substance can be equilibrium. Next, solid liquid equilibrium. Here, first we will discuss. When a solid is heated, it starts melting at a certain fixed temperature, that is a melting point. At this stage, even when the heating is continued, the temperature does not change until the whole of the solid is converted into liquid. That means, for example, ice, put the ice in a container and heat up, so the ice become liquid. While changing solid to liquid, the temperature will not increase. The state when solid and liquid phase of a substance coexist is called the solid liquid equilibrium. Here, if you move to that means here Solid to liquid equilibrium means we discussed here that it happened, that is state when solid and liquid phases of a substance coexist is called a solid liquid equilibrium. Next, gas, solid gas equilibrium. The state, it states that the mass of a gas dissolved in a given mass of a solvent at any temperature is proportional to the pressure of the gas above the solvent. This is a solid liquid equilibrium. Next, here the triple point. Simply put, the triple point of a water is the only temperature at which the water can exist in all three states of matter. That is solid, that is ice, liquid water, and gas water vapor. This temperature is 0.01 degrees Celsius. At this point, the water exists in three phases, that is solid phase, liquid phase, and gaseous vapor phase. This called triple point. So far, we discussed important topics shortly about equilibrium phases. That means phase equilibrium. We have done. Please subscribe our YouTube channel.